This is a quick video to review one of the articles we are reading this week. Suleski and Ibaraki's Scientists Are Talking, but mostly to each other. The article begins with a debate between scientists and journalists, often with some finger pointing in terms of who is responsible for the lack of communication to the general public. The quote says, "Journal publication, which is academic sources, peer-reviewed articles, has long been relied on as the only required communication of results, tasking journalists with bringing news and scientific discoveries to the public." So this is saying that journalists only have access to these articles that they then try to translate for popular media sources. The overall reliance scientists place on journalists to communicate research findings to the public seems at odds with their low opinion that scientists have of journalists, especially when coupled with the widespread sentiment among scientists that journalists are failing to accurately present research findings. So here we see some of the issues that scientists are having with journalists, whether or not this is true. This is based on their perspective of how journalists are not correctly interpreting the academic publications that are out there. And then there is this misrepresentation among the public regarding the results. So this is the overall point of this article, and they also give both sides, but this also ties in nicely with the purpose of this course, to find kind of a happy medium, or at least understand that both sides need to start working together in order to resolve the issue. So most of you know a scholarly peer-reviewed journal is an academic publication that experts in the field will typically write, and they are unpaid for this publication. They write to these journals as part of their tenure, their research, their medicine, for their hospital, institution, or university that they're working for. And this often is a requirement of their yearly duties, and can result in loss of a job if they don't complete a certain number of publications per year. But they are also not paid in the same way that a journalist is. While a journalist is paid per article, how quickly they can produce articles, the length of the article, how many people view the article, and the compensation varies depending on the topic and interest from the public. So they're very different types of publications, which is part of the problem where both are not understanding of the other's position. But it also shows you how difficult it is to publish in an academic journal, and that there is typically less bias surrounding these publications because the authors aren't paid. Here is a recent survey from the 2017 academic journal subscriptions and how much they cost per year. So some of these journals put out one publication per month, some are quarterly, and this is just for 1 year. So for one journal in a chemistry discipline, an individual would pay up to $4,700, or could pay more than that. That's the average for chemistry-focused academic journals. So this also starts to become an issue with when journalists are trying to get access to these articles and these journals that are very expensive. So the general public doesn't have access to these. Journalists might have some access or some ability to gain access to a few, but it really shows you the landmine you're sitting on as a CSU student who has access to all of these types of journals within your tuition. So it really is a wonderful capability that you have to search through all of these. And I know that it's daunting because they are so difficult to get through. But the more articles you can look through, the more you can compare and contrast, the better you're going to understand what's happening in the research, the better you're going to be able to communicate it to others, and the better they're going to be able to understand. This also shows costs per title on average in other disciplines. So you can see that the article talks about health being one of the most important or popular topics that journalists write about in sciences. And here you can see that health journals are quite a bit less on average than some of the other hard science journals. But you can also see the spectrum. So that might also be an inclination into why health is such a popular topic. It also relates more to the public, and then they're going to have more interest in it. So all of these factors contribute to the types of articles written, the topics that journalists are choosing, and what's selling to the public. One of the other issues noted in this article is that science journalists are most often noted for their failure to include qualifying statements regarding research. So this is also because a lot of journalists just look at one research article and then they say the findings for that. Well, within any discipline and within any specific type of research, there are multiple groups of researchers from all over the country and all over the world looking at that topic with a different group of participants, with different methods, different sample sizes, and different perspectives. And so looking at just one of those can't possibly give you a concrete answer as to what someone should or shouldn't do with that information. So making sure that you're qualifying that with noting that this is just one study within a large realm of studies, or comparing and contrasting many, showing the differences in their results, can help say that some results were found, some things were statistically significant. It might mean that there is a result or an effect, but that doesn't mean it is conclusive or a sweeping generalization. So really telling your readers that coffee doesn't cure cancer, but there is a correlation between drinking coffee and types or diagnoses of cancer in some cases. So some of the main takeaways from this article are that scientists judge between 8 and 30% of articles are error-free when they're written by journalists. So that means at the least, or at the most, 70% of the articles that you read are going to have errors in them. Now, this doesn't say what type of error, and some may be larger than others, but if you think about all of the science reading you've done that hasn't been from academic journals, that is on Facebook or in magazines or newspapers, 70% to 91% are likely to have some type of error. And then 91% of scientists believe that journalists fail to understand the nature of science. So this also shows that a lot of journalists don't have a background in science, and they often don't claim to, but that is part of their tasks as a journalist, is to communicate with the public. And so their attempts are what they do know about science, but perhaps not understanding the full nature. And then that gets into some issues with translation, interpretation, and communication. They also explain that the public's scientific literacy is dismal. So, for example, in 1992, 55% of survey respondents believed humans coexisted with dinosaurs. Now, again, we'll want to check the methods of this study to see how many people that they surveyed, and where this, who they surveyed, what their education levels were, where they were located. To find these results, but it does show that there are some audiences that lack crucial information where they're not able to then understand or feel informed about new scientific discoveries, which also starts to lead into the public as being a bit to blame as well for not being educated enough or interested enough in some of these important topics that can help change the way that they live or the world works. So this article is a really great example of a scientifically structured argument. You can see it has the introduction, the methods, data, results. It can help start to familiarize yourself with those types of experimental, peer-reviewed studies that you'll want to start reading and collecting for the writing that you'll do in this class. So I hope that this was a helpful article in that sense. Please let me know if you have any questions, concerns, or things to add. to this conversation, as I think this is just one place to really start talking about what we're doing here in CO301B, why it's important, and how it could apply to our future goals or directions.